Namaste student, this is Sanjay Nath. Today's session is on Volcanism, Chapter 7, Part 2, ICSE Standard 9. In our previous part, we already discussed about what are volcanism and how volcanic activities are very commonly found at the plate margins. The three different locations where the volcanic activities are very common: at the divergent plate boundary, at the convergent plate boundary, and over the hotspot. Now in this part, we learn about how volcanoes can be classified on the basis of their shape, size, and their eruption. But before we understand the classification of volcanoes, we'll see the major locations of volcanic activity around the world. As you can see on the map of the world, these red dots are representing the volcanoes. These are active volcanoes. And you can make it out, this particular zone is called the Pacific Ring of Fire. This plate is said to be the largest plate. And here you can see these dots are representing the active volcanoes. At this plate margin, the plate is meeting with the continental plate at the convergent plate boundary and has given birth to one of the active volcanic zones of the world. There are many other good examples of volcanic activity. As you can see in these red dots are representing those areas. Now we look upon the volcanoes on the basis of the shape. So before we classify the volcanoes on the basis of the shape, we'll understand what are the type of molten materials are responsible for the shape of volcanoes. As you have learned that there are two types of magma, granitic and basaltic. Now, granitic magma is acidic in nature and basaltic magma is basic. Now we'll understand how conical or composite volcanoes form. As you can see in this picture, this is the cone-shaped volcano where the magma pile up on the either side of the vent and they shape like a cone. Now what are the requirements for the formation of a conical composite volcanoes? Lava erupting from such volcanoes are thick and viscous. Conical volcanoes are a result of thick magma. When the molten material in the form of lava they solidify on the slopes of the volcanic cone, it solidifies very fast. Before this lava flow far from the cone, it solidifies on the slopes and give birth to conical shaped volcanoes. It is generally confined near the vent and does not travel far due to viscosity to thick magma. The resultant shape is of conical volcano. They primarily form due to the granitic magma flow. Example, Mount Fuji in Japan. Now the second type of volcano on the basis of shape is shield volcano. As the name suggests that the shield volcano from the top appear like a shield shape. Such volcanoes are not very high. They are mainly formed due to the molten material that flow on the either side of the volcanic cone. Such volcanoes are mainly formed due to the basaltic magma, and basaltic magma is more fluid in nature. When the molten material flow on the either side of the cone, it flow far and give a shape of shield. The lava is from volcano is thin and fluid. It is not confined near the vent, it travels along the distance. Volcano does not grow high but grow in lateral extent. As you can see, such volcanoes, their width are more. The best example as you can see in this sketch, Mount Rainier has been compared with Mauna Loa. Mauna Loa is a volcano over Hawaiian chain. Hawaiian chain of volcanoes are shield shaped. The base of such volcanoes are very wide. As you can see, is more than 190 km in width, and the height is about 4,000 meters from the sea level. The third category of volcano on the basis of the shape is fissure volcano. As you know that majority of the volcano, they ooze magma through a vent or a pipe and they flow on either side to form conical shape or shield shape. But such volcanoes called fissure shaped volcanoes, they form due to crack on the earth's surface. There is a long crack and through which magma flow on the either side and they form fissure volcanoes. The lava erupt out of a crack, range from few meters in length to few hundreds of kilometers in length. The lava distributed over a large area and several thousands of kilometers in extent. Rather building a cone or a shield shape, instead the lava flow far from the fissure and it appears to be flat top hills. Primarily the magma that oozes from the fissure type of volcano is basaltic magma. Basaltic magma is thin in nature, they are basic. The best example of fissure type of volcano is East African Rift Valley. Volcanoes can also be classified according to their activity. There are mainly three types: active, dormant, and extinct volcanoes. The name itself suggests that the active volcanoes, which are either in a constant state of eruption or which erupts at least once in 10 years. But please do remember, it at least erupts once in 10 years. Active volcanoes, according to the order of appearance, they're either at the divergent boundaries or over hotspots. The examples of divergent boundary volcanoes: Krafla, Loki, Hekla, Ketla. They're primarily in the island country of Iceland. Iceland is primarily located exactly over the mid-Atlantic ridge. The best example of over hotspot volcanoes are Hawaiian chain of volcanoes. Exactly over the source of magma, The volcanoes are Mauna Loa, Mauna Kea, Kilauea volcanoes in Hawaii. These are some of the good examples of active volcanoes over divergent and over hotspot. Now the second type of volcanoes that we learn is dormant volcanoes. The name itself suggests that these volcanoes are sleeping, which has not erupted in the recent times or in history. They are capable of eruption at any point of time. They are mainly classified as dormant or sleeping, that I have already told. When they erupt, they are very violent. Most of the world dormant volcanoes are found at the convergent plate boundaries. The best example of dormant volcano is Mount Fuji in Japan. The sudden shifting of the plate may cause a dormant volcano to erupt very violently. The other example of dormant volcano is Krakatoa volcano in Indonesia, apart from Mount Fuji in Japan. The third category of volcano is called extinct volcano. The name itself suggests that such volcanoes are no more active or alive. Such volcanoes which have not erupted in the historical times, which never erupt again. Such volcanoes are primarily located at the ancient plate boundary, or they might have shifted due to a plate tectonic movement. Volcanoes were created when the plate passed over an active hotspot. Now such volcanoes are no longer on any active hotspot, they have shifted. The eruption dies down or they just stop. The best example of extinct volcano is the Mount Kilimanjaro in Africa continent in Tanzania, and there are many examples of extinct volcanoes from India, Deccan Plateau and the Girnar Hills in India. More detail about the volcanoes will come in the next session. Now we learn about the features associated with the volcanic eruption. As you see in this picture, there is a picture of a geyser. Such features are very common near the volcanic areas where the water gets heated up and shoot towards the sky with tremendous pressure. Primarily beneath the ground, if there is a magma there in the magma chamber, it heats up the surrounding rocks, and these rocks are more resistant, it doesn't get easily eroded, and it has given birth to hot springs or geysers. Now if I draw the cross-section view of this geyser, somewhere little bit inside the earth, the cracks and fissures filled with water, and this water mainly seeps through the wall of this crack. When the water inside this crack reaches to the boiling point at 100 degrees, the molecules of this water started expanding and creates some pressure, and somewhere this pressure is to escape. Now through these cracks when the water shoots up toward the sky, it appears like a fountain. Such hot water shooting toward the sky are called geysers. The water in the fractures gradually heat up, and near the boiling point that I've already told, about 100 degrees Celsius, the water down there deep inside the crack, they reaches up to the high pressure. The pressure cannot withstand further and it shoots upwards. Now these features are very common in the areas where volcanic activity is very frequent. Example, New Zealand, Yellowstone National Park in US. Now other associated features are hot springs and bubbling mud pool. As you can see in this picture, there is a hot spring and people are taking dip into this water. There is a belief that such hot springs have some medicinal properties. If the surrounding rocks are more resistant and the water slowly appears on the earth crust, and water here is near to boiling point. In this situation, water doesn't shoot up very high like a geyser. It appears and is very hot. So such hot springs are very common in the volcanic areas. There's a difference between the hot spring and geysers is that in geyser the water shoots up, but in the hot spring the water simply appears on the earth's surface. And these areas are very commonly found in India also. As you can see in this picture, this area is in Manali called Vasisht Kund. Now we learn about bubbling mud pool. Bubbling mud pool is a result of chemical reaction, where the water slowly eats away the rocks in the fractures, where the water heats up near the boiling point and rock get easily dissolved with the water. It creates a muddy situation, and this is due to the chemical reaction. Now due to chemical reaction and the high pressure, this forms the bubbles on the surface out on the earth crust, and these bubbles are escaping gases and steam, and it appears like bubbling mud pool. Thank you for watching the presentation.